All right. So we did. I mean, it took us 2 hours to do these five, which was kind of insane, but it was very helpful. We're gonna do number 6 now. I got a brand new notebook here. Already the spiral is giving me annoying problems, but that's fine. Okay. Y dot is equal to A minus absolute value of Y. Set it equal to 0. Set equal to 0. And so we have absolute value of Y is equal to A. So that means that so Y is equal to plus or minus A. Wait, but if A equals minus 1, right. Okay. Now I understand. So what's happening is if A is less than 1, there's no solutions. If A less than 0, if A is less than 0, then no equilibria. If A equal to 0, 1, Y equal to 0, and if A is greater than 0, then plus minus A are Y equal to plus minus A are equilibria. So we're going to have three phase lines to draw. We're going to have the A is less than 0, so A is equal to, let's say, minus 1. So so this is going to be interesting because I'm so bad at let's see. How do I do linearization test when we have an abs val? Okay, yeah, so you do a piecewise derivative. So we have f prime is equal to minus 1 for y greater than 0 and 1 for y less than 0. Duh, obviously. Okay, that's good though. So if a is equal to minus 1, then we have no solutions. But then what? The phase line where a is equal to minus 1. There should be no sols, but how do I know? Because it has to be negative. So it's negative. And then we have our next one, a equal to 0, y equal to 0. So if we did, okay, so it's going to be down down. Now the last one, a equal to 1, we're going to have 2 points. Y equal to 1, y equal to minus 1. So when a is 1, we're going to have 1 minus abs of y is equal to 0. So when we split it apart, we're going to get 1 minus y. I hate absolute values. Dude, absolute values are like so lame, bro. Alright, so if y is greater than 0, so I think this one is going to be a sink. The y equals 1 is going to be a sink. This one's going to be a source. Why don't we just do this? This is what we should be doing all along. We have nothing and they're negative all the time. And then it crosses, and then we get this, where the lower one is a source because it's going to go away, and then it's going to go to this guy. Always just plot the function. I think that's the key thing. Just plot the function, and then it'll be a lot easier to see what the issue is. All right, number 7. So we have locate the bifurcation values for alpha for the one parameter family and describe the bifurcation that takes place at each value. Okay. So we have y to the 4th minus ay squared is equal to 0. It's just so cool how, I mean, really understanding differential equations is got to be so sick. Because if you think about it, it's like, for the most part, all of these examples, it's more general than the function space or the class of functions of polynomials, because you have these exponentials in here, you have these trigonometric functions, but it's, for the most part, all about studying zeros. I mean, that's what it seems like, because you can characterize so much of the behavior just based on what happens around the zeros. Anyway, so if we factor, we get y squared is equal to y squared minus alpha. So this is actually a pretty easy one, I would say, because we can factor it even more, where I mean, we don't need to do this, but y squared times y minus alpha, y plus alpha. So the bifurcation is clearly at, so let's just say if a is not equal to 0, then the equilibria are 0 plus minus a. So we have 3. But if a equals 0, then we have a 3-to-1 collapse. I still want to plot it out. So what we're going to do is 3 phase lines. So this is a equal to 0 in the middle, a equal to minus 1, and a equal to 1. And so, so in all of these cases, we are going to have the 0. The 0 never goes away. And then if a equals minus 1, so then we're going to have y squared times y minus 1, y plus 1. So we're still going to have uh, 0, 0, 0, y equal to 1, y equal to minus 1. Wait. Is that true? Wait, I think that's wrong. Wait, I'm so I messed this up bad because there's a square root that I forgot. So so we're doing this problem, and if and so anyways, we have y squared is equal to a. So then y is equal to square root of a. No. See, I totally botched this. Yeah. So no, there are no for a is equal to minus 1. There are no. Or no. There are no equilibria besides the 0 equilibria. So yeah. So here's what's happened. So but here at a is equal to 1, we get y equal to 1, y equal to minus 1. I don't know why I haven't learned my lesson. Let's do this. How many times we got to teach you this, old man? All right, so we got x squared times x squared minus a. Yeah, oh, okay. So yeah, it's just yeah. Okay, and then describing them, we're going to get f prime of y is equal to 4y cubed minus 2ay. So at 0, it's 0, inconclusive. But we can see from the graph right now that it's going to be down, down. Just plot the derivative, bro. Just plot the derivative. It's like this makes your life so much easier. All right, so we're going to have that, but then it's down here. So, but it's positive above. What is this going to be? Oh, if y, let's make a equal to 4. Or actually, let's just make a equal to 1. That's best. So we're going to have the top one is clearly a Wait. Wait. Is that right? Okay. Okay, so I believe that it's like a 1 to 3. That's all upward outside of the sideways parabola. And then inside the sideways parabola, it's double down. So somehow that node kind of flips, or I got it wrong. No, it has to be that. So if we did y equal to 1, or a equal to 1, y equal to -1 on the linearization, we're going to get oh wait, am I 4 times -1 minus 2 times 1 times -1. So we're going to get -4 plus 2 is equal to -2. Yeah, we're good. Okay. 7 has been completed. So how would I answer this? I would say that a 3 to 1 collapse from where a source and sink come out of a node which sticks around. For a greater than 0. Dude, number 8 looks ridiculous. We need to hurry up, though. I don't really have that much time. It's already... Dude, I don't have that much time. I am stressing out. It'll be fine. I feel like it's going to be something like this, though. We got to get to these. All right, let's hurry up. So y dot is equal to y to the 6 minus 2y cubed plus a. Excuse me. I don't know how to do this. Ah. Oh my god. Okay. That's pretty interesting. This one's cool because alright, so let's say a equal to 0. Y to the 6 minus 2y cubed is equal to 0. Wait, why are there 3? Oh, really? You can do that? Oh, wait, this is wrong. This is wrong. Oh, wow. Okay, so for a equal to 0, wait, that's not true. Yeah, that's why you can't divide. You can't divide by the y cubed. You have to have y cubed. You have to factor times y cubed minus 2 is equal to 0. Now we have 0 and cube root of 2. Wow, the difference between even and odd powers is like a big deal here. Okay. All right, so we're going to draw 3, a less than 0. How do we find that one? I don't know how to find that one. Okay, so if we need to go back to the book. What did it say? I mean, I think we can say that um right, like right now this has 3, and what we can say is that if it's of this form, we can make it go to 1 this way, and we can make it go to 1 down. So if we shift it down, so wait, if we did this, like, wait, okay, like this, we can control it. So is there something about, I mean, in all of these cases, the endpoints tend to infinity. Okay, we should do an x cubed plus 2x plus a. I want to see that because that's like a simpler case of what we have going on here. But I think the point is when we have this form, we can we know that there's going to be a bifurcation point for when this thing goes up and passes the y-axis, and then similarly for this. So all of the extrema, local extrema, yeah, this is going to be really interesting when you get like way more complicated functions. I don't know. But I guess what I'm trying to figure out is, let's just ask. So, or yeah, critical points. A fold? I don't know what a fold is. Find the critical points. Yeah. Then you compute. What are we trying to say? So wait, let's not do this one, but the original one. The original one's interesting because as oh, but you know what though? It doesn't actually change. I wonder if oh, it doesn't actually change. When you go from if you drop this down, no matter what, this thing stays a sync. So the only real bifurcation value is y equal to 1. That's actually crazy. A equal to 0 is not a bifurcation value because um, it starts as a sync and stays a sync until the equilibria around equilibrium around y equal to or y equal to 1 dies. Oh wait, but we have 2 though. What am I talking about? We have 2, right? But we always have 2. Yeah, we always have 2. Wait, but now I'm getting all mixed up. If a is equal to 0, dude, polynomials are so crazy. Polynomials are so crazy, man. All right, I'm gonna make some food, and we're gonna finish this stuff up. Okay, so I feel like I understand number 8. All right, let's do number 9. So what does the bifurcation plot look like? A 2 to 1 at it's a so so wait, for what value of alpha? Alpha equal to 1. A equal to 1 is by the only value, and it's a 2 to 0 collapse. And basically it turns a it's actually interesting because it turns a let's just make a bigger just so that we see this. So oh wait, we have no. What am I talking about? We have 2 points. This one is a sink, and this one's a source. Okay, but then it goes into a it goes into just something that points up. So the sink dies. Or well, they both die, but it ends. Yeah, they both die, but it ends up. Well, actually, No, yeah, so okay, this is what we want to do. So it goes from a 2 with a source on top into something with a 1 where it's semi-stable going upward, and then finally it's just upward. So that's what the answer is. Okay. Ooh, sine is gonna be fun. Yeah, something periodic is gonna be cool. So basically what happens is we're gonna get a line. So at a equals 1 and minus 1. So okay, so let's do a equals minus 1. So okay, let's do. Okay, so number 9, let's start with one line that's a is less than minus 1. We're gonna basically get a downward arrow, and that's it. Then we go to a is equal to minus 1, and we get a periodic dots, and at all of these dots, they're all semi-stable. So we have an infinite number of semi-stable nodes that are pointing down. So down, 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 down. Now at a equal to, at a in between, so now we have like, say 0. 0 is a good number. At 0, a equal to 0, we're going to have just an infinite collection of alternating, right? So, like, because, like, you're going to have, this is a source. We're going to have, like, a source, then a sink, then a source, forever. Then once you reach so the bifurcation, so a equal to minus 1 and 1 are the bifurcation values. They create, destroy, they are infinite number of nodes that all die or form alternating source sink. Okay, then lastly, for a equal to 1, we have up arrow, up arrow, up arrow, up arrow, and then a equal to greater than 1, it's just going to be a pointing up arrow. This is really cool. That's cool stuff. So when okay, sine was easy, but it was really cool. All right, so number 10 is y dot equals e to the minus y squared plus a. Oh, this one's gonna be kind of interesting. Okay. Oh yeah, let's do number 10. This one's gonna be interesting. My default for f of y equals my for all of the ones like this, let's just start with a equal to 0. So we know that okay. So wait, again, let's just freaking graph it. I don't know why I'm being so lame, dude. Dude, why am I being so lame? Wait, what? Wait, what am I talking about? That's it, right? Oh, cool. I'm gonna delete some of these. So we have like a 0 to 1. Or no, wait. We have like a 0 to 2. And then, ooh, actually, you know what? For what value? Oh, no, but that doesn't make sense. Because there's no endpoint to this graph. Oh, so the cool thing is finding... In a sense, a equals 0 is a bifurcation value, as well as... What is this value going to be? -1. Yeah, because if x... So if we have a 1 over e to the y squared -1 equals 0, then so then y equals 0. Y equals 0. So bifurcation values are a is equal to 0, a is equal to -1. Because if you nudge this just ever so slightly, then at some value, at some point, these things are going to cross. All right, let's just see what it says. I want to know what the bifurcation diagram is. So just see what it says, and then we'll go from there. Greater than or less than? Less than. I I want to see what it says because it feels like a at 0 is also. I don't know this terminology. Okay. Okay. So we did like 12 problems in like 4 hours. That's so cool. Or 3 hours. Oh yeah, wait. It's time. Okay, so now that we have 11, it's time to actually do that with this one. Okay, so wait. Y dot is equal to minus y cubed plus 2xy plus a. So just do a is equal to 0. Oh, wait. This is stupid. I think that's right. Right. Okay. This is good. Cool. So there's 4. One to 4. That's pretty cool. 1 to 4 change. Oh wait, what am I talking about? 1 to 3. I don't know about this one. Wait, 2 to 1. Wait. What? No, that's just, yeah, I don't know what I'm doing. Okay, I think this one, I is this. I love these plots. This is great. Yeah. Down, up, down. Okay, so I'm pretty sure that's true. So now let's do number 2. So a plus y squared. So this, nope. Okay, this is none of them. This is none of them because the parabola goes to the other side. Transcritical bifurcation. Yep. 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 That's exactly what I got. Damn, this plot is good. All right. I'm getting fast, dude. But we really gotta hoodie it up. Wait, what? No, wait, something's wrong. I think. Is that true? I feel like that. Yeah, I mean that's true. I don't know what I'm tripping about. Yeah, I don't know if this is. I mean, this is. So this one. No, wait. Wait, hold on. I think A is. Yeah. See, I'm using my. I'm being biased. I'm using my previous experience to cloud my judgment. If you look at this, we have y less than 0. This is clearly a stable thing. And then it becomes unstable, and we get too stable on the outside. You just always look at the plot. The plot is the easiest thing to do. Okay, so if we were to keep going, so we had so okay, so for I plot D because we see a family of equilibria at y equal to minus a. Number 2, I don't think did we see anything in number 2? We didn't see no plots match. Okay, this one is plot A. I'm loving these bifurcation plots. This one was good. So this one we should see a stable line here. Well, why did they do it so differently than this stuff? I like the other style more. We can't see anything in there. Supercritical pitchfork bifurcation. So one stable becomes two stable. Okay, wait. We got to start charting some of this out. So ay minus y cubed is a, what is it called? Supercritical pitchfork, where one stable goes to 2. But if we had y cubed minus ay, for instance, if we flipped the sign of this, and we did x cubed minus ax, here we have an unstable. We have one unstable goes to 2 unstable. So we start off with one unstable, two unstable, stable, unstable. So this is like, okay. Okay, yeah. So if we were to flip the sign on number 2, what was it? A minus x squared. So here we have unstable, 2 unstables. Or no, the top. So, okay, wait. So as this is negative, we get nothing, then we get 1. So this is, so the parabola gets flipped around. So in part 4, we have a minus x squared, and we get and I think the top one is stable and the bottom one is unstable. So that matches none of these plots. Now let's just double check though that I am right. Almost positive that it is. It's going to be a parabola on the right-hand side that has a stable on the top. Yep, there we go. Oh, see, that's actually not, this isn't inverting it. Yeah, okay, so this one, so these are minus of each other. So when you have y squared equals a, oh, does that flip it from bottom to top? I think that that's going to be, I think that that might be B. Let's see, what do we have so far? We had I went to D. We had 2. 2 was nothing, right? 2, yeah, 2 was nothing. 3 was, 3 was A, actually. 3 went to A. And then 4, I don't know if we know yet. I think 4 went to nothing, right? Oh, man, it's already 3? Holy shit, I only have 3.5 hours before my test. I am stressing out. Okay, so, okay, so, but V is going to be y squared minus A. So we have, y squared equals A. So if A less than 0, no solutions. So then we're definitely going to have a parabola sideways to the towards A positive. And then the only issue is now we have 2y is f prime. So then we have, we know our solutions are going to be y is equal to plus or minus square root of a. So let's say a is 1. So a equals 1. So now we're going to have y equals to plus or minus 1. So on the minus, we're going to have a minus. So therefore, the bottom is now stable. So now we have a, is the characterization. So that one, that is B. So V goes to B. So what happened? What changed? Basically, all of the signs flipped. Yeah, so all of the arrows flipped when we multiplied the when we took 4 and multiplied it by -1, we just flipped all the arrows. Now we're getting pretty fast at these basic ones. AY plus y squared, we get y times a plus y. So we get y equal to a minus a. So then, and we always have 0. So we're going to have, so I think it's going to be like this. It's going to be like a, up, up. So I think it's going to be like this one, but it's not. So did we get them all? No, wait. What did C look like? Did we get any C? Oh, no, wait. 4 is C. Yeah, 4 is C. All right, so that's my answers. All right, we did that one. Okay, so we're going to say 1 minus cos x plus 1 times a to 1 plus cos x. All right. 1 minus cos x plus a times 1 plus cos x. If a equals 0, no, if a equals 1, we get a flat line. For the derivative, so it just goes always up. But then, okay, that's fine. So then, but what we care about is this critical point when a is equal to 0. Okay, but then here, so what happens is at a equal to 0, we get infinite number of these nodes that point upward. So if we go back to 0, so these are all going to be positive on this side, positive on this side. So it's going to be pointing up. However, you know what, though? I haven't really done any practice with plotting solutions. I should be plotting some of the trajectories of these things. Okay, anyways, but for, I think it's going to be a less than. For a less than 0, we get an infinite number of alternating source sinks. For a greater than 0, no solutions. But points up. Okay, great. Is that what they were asking for? They were saying, suppose is a constant function, describe the bifurcations that occur. No, that was 14. 15. Bifurcation. All right, I need to get some food in me. All right, I'll be back. How could you be so evil? Oh wow, there's a lot more of these. Holy cow. Oh yeah, we read this one yesterday. I wanted to do that one, but I think given how much time we have, it's already 3:15. I only have 3 hours of studying left. I think it's time to just switch to review. So I'm going to end this stream, start a new one in a minute about just 1.1 to 1.7 review. We're probably going to start off, maybe scan the sections just to remember what it is, write some notes on that. But then I really want to do review exercises because review exercises are really good. Okay, so that's it for bifurcations.